All right, so the last two types of functions that we're going to take the derivative of are the natural exponential function and the natural log function. All right? And what's wrong with this picture? Can you see it?
It says e to x.
Yeah, natural log function says e to the x for whatever reason. That is not the natural log function.
It's the ln.
It's ln of x. And bear with me, because anytime I start doing ln's, I start writing h's for whatever reason.
Oh,
So,
that's so cute.
ln of x. All right, so if I write an h, just understand that that's ln. All runs together. But here's the deal. Again, the rules here are not that hard. Okay, let's take a look at the basic rule. First of all, the derivative of e to the x is e to the x. That's kind of nice. All right. The derivative of natural log of x is 1 over x. All right. Those are just two things you need to memorize. Okay. But where it gets challenging, same thing as we saw with the trig functions, where it gets challenging is when you don't just have an e to the x, but you have e to some function. There's some function in the exponent. And anytime you have a function inside of a function, you have to use
chain rule.
Chain rule, okay? You have to use the chain rule. All right, so here, if I have e to some function f of x power, the derivative is just e to that power times the derivative of the power. Okay? And then, same thing here, if I have ln of some function, it's 1 over that function times the derivative of the function. So we simplify that to f prime of x over f of x. Okay, we'll do some examples here in a minute. One other thing I want to point out here is, don't forget the properties of logarithms. Okay, if you have ln of, say, an x squared plus 5 over e to the x, you have ln of a quotient. You can separate that into two separate natural logs, ln of the numerator minus ln of the denominator. Okay? So, don't forget these rules that actually will make life a lot easier for you. Okay? So, let's look at how these work. And basically, what I've given you here is I've given you several problems to try. And what I'm going to do is I'm going to kind of pick and choose out of these. The rest of these are the homework for this thing, and that's what we're going to spend more time today working on. Okay? So, for example, let's start out with h on this. It says find the gradient function. That's a fancy way of saying what?
Differentiate.
Yeah, take the derivative. All right? So on h, we have e to the x plus e to the negative x over 2. Now you guys know that if I have it just over 2, that's just times a half. So I'm multiplying by a constant. So I can just write this as a half times the derivative of that e to the x plus e to the negative x. Okay? Well, now I'm going to take the derivative of each part. The first part here is just the basic rule. The derivative of e to the x is e to the x. All right, so we have 1/2 times e to the x. Now, here's where the chain rule comes in, because this is not e to the x, it's e to the negative x. All right, so you're seeing negative x as a separate function. Okay? What's the derivative of that?
Negative e to the negative 2. Is that how?
Isn't that just negative 1?
No. Well, the derivative of e to a power is e to a power. Okay, so that just stays the same.
Oh, so that'd be like
Well,
times the derivative, which is e.
times the derivative of the exponent. What's the derivative of the exponent? Negative 1, okay? And you can even write this out like you did with the chain rule. U here is negative x, u prime is negative 1, g of u is e to the u, g prime of u. The derivative of e to a power is e to a power. Okay? So the e to the u is the e to the negative x times a negative 1. Okay? So this is just 1/2 e to the x minus e to the negative x. Okay?
Should we just leave e to the negative x?
Well, there what we can do, okay, you can distribute the half or you can leave it out. We can make that e to the x over 2 minus 1 over 2 e to the x.
But don't you have to multiply by negative 1 so that it's pi? Because in the first one it was minus e to the negative x.
Well, that originally it was plus.
Oh, I thought it was
Okay.
minus,
Yeah, originally it was plus, so we brought the negative down. Okay? So that's our completely simplified.
And so that will be our final answer.
That's our final answer. Okay? But again, that's how we use that chain rule with our e to the x power. Okay? Let's try another one. Okay? Let's do, what do you want to do? Let's do B. Okay? Alright, so this one, we have the chain rule a couple of times. Okay? We have the chain rule a couple of times. So the first thing I'm going to do here is rewrite y as 2 minus e to the negative x to the negative 1. Okay? Now, what's the outer function here? Yeah, the outer function, something to the negative 1. Okay? So we have g of u is u to the negative 1. Okay? So g prime of u, yeah, negative 1 u to the negative 2. Okay? Now what's u here? Yeah, 2 minus e to the negative x. Okay? 2 minus e to the negative x. Now, I've got to take the derivative of that now. Okay? To do u prime, the derivative of 2 is 0. Okay, so it's 0 minus, and now the derivative of e to a power is e to the power, so it's minus e to the negative x.
And then you have to do times negative 1.
Now we've got to do chain rule, so times negative 1. Okay? So notice here I'm doing the chain rule inside the chain rule. Okay? We can have more than one link in the chain. Alright, so this would simplify to make u prime be a positive e to the negative x. Okay?
Maybe multiply e to the negative x times u to negative 2. Well,
That's
negative
right.
to negative 2.
Yeah, we've got the g prime of u, which was negative 1, and I'm going to simplify this. It's over u squared. So the u was the 2 minus e to the negative x. Alright, so when I am simplifying here, dy dx equals a negative 1 over 2 minus e to the negative x squared times e to the negative x. Okay?
I'm so lost.
It's just the chain rule. Okay? Our g prime of u is the negative 1 over 2 minus e to the negative x squared. The u prime is the e to the negative x. Okay? And of course, you can rewrite that as one fraction, negative e to the negative x over 2 minus e to the negative x
Why is it so-
squared.
Oh, yes.
Okay? And by the way, this is one exception. I told you always simplify the negative exponents. This I'm going to say is the one, would be the one exception. When you've got like this e to the negative x in the parentheses, okay, you can just leave that way. Okay? Now, in the numerator here, notice you have an e to the negative x, so what is that going to do? That's going to go to the bottom. So we can actually, our final answer, the e to the x would come down here. Now it's e to a positive x power, because we brought it down to the denominator, times 2 minus e to the negative x squared.
So we need to bring it all the way down to that?
You can bring it down to that.
We can't. We do not have to.
Well, like here, this negative exponent, you should go ahead and simplify that. But if it's inside this thing squared like that, don't bother with that.
Got it.
Okay? Now, the reality of this one, this particular problem is that it doesn't actually matter how far you simplify. Because are we looking for dy dx?
No.
When x is 0.
No. The problem is asking us to find the gradient of the tangent, or the slope of the tangent line, when x is 0. So really, as soon as I get here, I can plug in 0. Okay?
Thanks for fooling us.
So I show you this so that if you had this problem where it was just asking for dy dx, this is what you should do. But the reality is, in this particular problem, we could have plugged in 0 at any point along here and we'd get it. So at x equals 0, dy dx is going to be negative 1 over e to the 0 times 2 minus e to the negative 0 squared. Okay? Well, e to the 0 is 1. What's e to the negative 0?
Negative 1?
No, it's still just 1. Negative 0 is just 0. Okay, so we have 2 minus 1 in the parentheses, that's 1. We have 1 times 1 squared in the denominator. So this whole thing just equals a negative 1. Okay?
Okay. God bless you.
Alright, so the point here, guys, is to be careful and to recognize that, yes, the rule for e to a power is really easy. It's the derivative of e to a power is e to a power. But the challenge is when we start mixing other things with it and using that chain rule, sometimes even twice. Okay? Yes?
Okay, so e
Wait,
to
so we
the
can't
x
put
here is just e to the x, so we
Mhm.
wouldn't be like e to
Plus.
the, and then like 1 times e to the x minus 1, like, that's the
Yeah,
only
it's
time
not the power rule. That's one thing that you've kind of said this twice. I think I want to make sure we make this clear to everyone. X to a power is different than e to the x. We're not subtracting 1 here.
I know, I keep forgetting that. Okay,
Yeah,
so
and
it's
that's a
never the
common
same
thing.
as anything like that.
Yes, this rule only works when you have x as the part of the denominator, or a function as the base, and a number as the exponent. N has to be a number. Okay, so then you would do n times x to the n minus 1.
Yeah, I just realized that.
Here, e is the number, x is the variable. Okay, and you would have to just use this rule. Okay, even if you had x to the x, you can't make that, well, x times x to the x minus 1. It doesn't work that way. Because you'd have to have a number up here. Okay? To do that, not in this class. Not in this class. We're not going to mess with that. Okay? So, make sure you distinguish between those as you are doing your work. Okay? Alright. So, that's practice from that. I'm going to leave number 4 for you to explore. Okay.
Thank you so much.
Now, this I want to show you because this is not a rule that you need to know, but this is just kind of showing you how all these rules play together with the things that you learned last year in how to deal with logarithms, okay? So, by substituting e to the ln of 2 for 2, okay, notice e to the ln of 2 equals 2, right? E and ln are inverses of each other, so that just equals 2. But we're going to use that identity in y equals 2 to the x. The derivative of 2 to the x is not 2 to the x. That only works for e to the x. Alright, so what we're actually developing here is, I want to show you this one to show you how we can develop other rules, okay?
A question like this on the test tomorrow.
Don't worry about that right now, okay? This, okay? So we have y equals 2 to the x, which is now rewritten as e to the ln of 2. And that is to the x power. Okay? Now, what do we get when we raise a power to a power? Or how do we handle that?
Super.
What?
Multiply them.
We multiply it. So it's e to the x times ln of 2 power, right? We have a power raised to a power, so we multiply the powers together. Just like if you had, 2 cubed to the 4th, you'd make that 2 to the 12th. Okay? That's all we're using right there.
So why did you put that something kind of like that?
Well, because y equals 2 to the x power. That was our original function that we want to take the derivative of. Okay? So, we have 2 to the x, which, since I rewrote the 2, I can now multiply the exponents together and get e to the x times ln of 2. So now when I take the derivative, dy dx, the derivative of e to a power is e to the power. So e to the x times ln of 2 times the derivative of the exponent. What's the derivative of this exponent?
What? Okay,
Is it 1 over 2?
No.
1 over, oh, we have to do the derivative of that.
What does ln of 2 equal?
ln of 2.
ln equals 1 over x.
No, ln of x, the derivative.
1 over 2, isn't it?
No, it's because you have to do the function.
ln of 2 is a constant, right?
Yeah, so it's 0.
It's 2.
Well, but we're multiplying it by the x. So this is ln of 2 times x. So what's the derivative of,
Oh, so it's just ln of 2.
yeah, u prime
Yeah.
is just ln of 2. This is the power rule. X is to the first power, 1 times ln of 2, and then x is to the 0 power, right? Just like if I ask you what's the derivative of 3x, it would be 3. There's a constant times the x. ln of 2 is a constant.
Yeah,
Alright? We just don't recognize it maybe because it's ln. Alright, but, so here I have e to the x times ln of 2 times ln of 2.
That'll be the full derivative.
And that's your full derivative. Now,
There's more?
there is more, okay? And this is how we can actually develop part B, alright? I want to go further with this part A, and then we'll develop a rule for this for part B. And this is a rule that you would memorize if you were taking AP. We don't really mess with these in SL, but I want you to see how this all works together, okay? What did e to the x times ln of 2 actually equal?
2.
It equaled 2 to the x, right?
Yes.
So this, because remember, this was the 2, and that was raised to the x power. So this is 2 to the x times ln of 2. Alright? Well, if we were to look at part B, where it just has a constant b being raised to the x, let's work through this whole process. Just like we did. Instead of e to the ln of 2, I'm going to use e to the ln of b. Alright? So y equals e to the ln of b to the x. That's the same thing as b to the x power. Okay? That equals e to the x times ln of b. And now when I do the derivative of e to a power is e to the power times the derivative of the power. What's the derivative of x times ln of a constant? Yeah, it's just the ln of b. So guess what? I'm going to multiply this by ln of b. Okay?
Keep writing H's.
I shouldn't have said that. I actually haven't yet.
You will know.
Alright, so that's ln of b, and then e to the x times ln of b was, remember, e to the ln of b
Every time.
to the x power. So that's ln of b times b to the x. So guess what? We have a little rule here. And this is how these rules get developed. People start exploring and just trying stuff with numbers first, and they start to recognize a pattern. You know, they may have done it with with 2 to the x and 3 to the x and 5 to the x and recognized a pattern, so they try it with a random constant b, okay? And they try stuff, okay? So this is actually a rule for taking the derivative of any number to a power, x. Okay? So, okay? Not one that you have to memorize, but it's cool to see this kind of thing. Alright, so let's practice with a couple with the natural logs. And I want you guys to make sure that you're paying attention to how the chain rule is working. Because on these, this is just like with the trig. Remember how we did sine squared of x and then we did sine of the quantity x squared?
Yeah.
You had to pay attention to what's on the inside and what's on the outside. The same thing is true here with our natural logs. If you look at h or I as opposed to, you know, B or C, you'll notice that in B and C, the outer function is the natural log. Okay? For H and I, the outer function is the square and the square root. Okay? So I want to do two of these. I'll do C and I, and you guys can do others practicing on your own. Okay? So, again, chain rule, G of U in this case is ln of u. What's the derivative of ln of u?
1 over u.
1 over u. Okay, so g prime is 1 over u, which in this case is 1 over the u is x minus x squared. Okay? So x minus x squared. U prime, this is the easy part, 1 minus 2x. Okay?
Just multiply them.
And now chain rule, we're using dy dx is g prime of u, so 1 over x minus x squared, times u prime, 1 minus 2x,
That's it.
which we would want to write as just a fraction, 1 minus 2x over x minus x squared. Okay? And this is where you saw the formula that you were given on the first page. It was f prime of x over f of x. Okay? That's kind of a simplified version of this. Okay? So there's our dy dx.
Can I leave it like this?
Hmm?
Can I leave it like that?
Like how I have it written there?
Yeah.
Yeah,
Okay, cool.
leave it like that.
Thanks.
Yours, you would want to put that together in one fraction though.
No, that's what I'm asking. Do I have to?
Oh.
do it on that?
Yeah, multiply, put that together. Put that together. Don't leave it like this. And you'll see why later as we get into our next student, we start really applying all of this stuff, you'll see why we want to put that together in one fraction.
You'll see dy.
Didn't.
Don't
You're
even.
funny sometimes, but that was just sad.
All right.
Terrible puns.
So, then we have I here, okay? Now,
I don't want
again, we need to do our g of u and our u. What's the g of u in this case?
Schmer? I don't know what it's called. U.
Radical?
Radical U.
to. What?
It's the first time I've heard that one. Radical u, or u to the 1/2, right?
Schmo.
And the u is the ln of
What
x,
does that mean?
okay?
Wait, I'm confused. What she
Don't
said.
worry about it,
It's just radically.
okay?
Schmo.
So g prime of u, what's g prime of u, guys?
1/2 U to the negative 1/2.
1/2 u to the negative 1/2, okay?
Competition deal.
So, that is 1 over 2 radical u, right?
Yeah.
1 over 2 radical u. Well,
What?
u to the negative 1/2.
Negative 1/2 is radical Schmer. So.
What is a
Okay.
schmer?
Navigating Schmer, I'm sorry.
Alright, so we plug u back in. 1 over 2 square root of ln of x. Okay? So that's the g prime. G prime, sorry, that should be of u. Okay?
My word.
Now, u prime is what?
Nope. I don't know. That's a good question.
What's the derivative of ln of x?
1 over
It's 1 over x. 1 over x.
Because that's the memory.
Okay. That's the thing.
He
So
showed it
dy
to us today. How do you
dx.
have it memorized?
So dy dx is g prime of u 1 over 2 radical ln of x times 1 over x.
Can you make that like 1 over 2x radical ln x?
Yes, you do want to do that. 1 over 2x radical ln of x. And that would just be our final answer. Okay? We don't need to rationalize, you don't have to mess with that, multiply by a radical ln of x over radical ln of x or anything like that. Okay?
So by the rule, if it was ln of like 7, it would be 1 over 7.
No, if it were ln of 7, that's a constant. The
Constant,
derivative
okay,
of a
makes sense.
constant
I was
is 0. Yeah.
But there's no x, so you wouldn't.
Yeah, so that's why if there were no x in there, if it was ln of a number, it would be a derivative of a constant.
So it's kind of like the normal derivatives, because it has to be, it's like not the powers, I guess.
Okay. Alright, let's do a couple more just to really get this down, and then we'll have you guys do it on your own, okay? D here, find the derivative of ln of 10 minus 5x. Okay? What's on the inside?
10 minus 5x.
The 10 minus 5x. So that's your u. U prime equals
Negative 5x.
negative,
No, 5.
negative 5. Okay? The outer function, g of u,
ln of x. ln of u.
ln of u,
one
so g prime of u,
over u.
1 over u. Okay? Which is 1 over 10 minus 5x. So,
Oh wait, this is
dy dx, 1 over 10 minus 5x times the negative 5. Okay?
Can you take a 5?
yeah, that's what I was doing. So it'd be negative
So,
1 over 2 minus x, right?
negative 5 over 10 minus 5x. You can reduce that. You could actually reduce it by a negative 5 even. And it'd be 1 over x minus 2.
Yeah.
If I cancel out a negative 5 from the bottom, it'll be a positive x and a minus 2. So 1 over x minus 2. Okay? If you canceled out the 5 only, it would have been a negative 1 over 2 minus x. Those are equivalent, so it doesn't matter.
Where'd the ln go?
We took the derivative of it. The derivative of ln of a function is the derivative of the function over the function. So the negative 5 over the 10 minus 5x. Okay? We're doing the chain rule every time. Okay? And guys, this is where we want to get eventually with these. We don't want to have to write out this whole chain rule every time. The rule on the first page I showed you that f prime of x over f of x. Okay? If you have ln of a function, the derivative is the derivative of the function over the original function. Okay? That's what we're getting every time with these. Okay? So if I come over here to C, eventually what I want to be able to do is simply write down the answer. Okay? The inside function here is the x to the fourth plus x. So what's the derivative of that?
4x plus 1. 4x cubed.
4x cubed plus 1. I put that over.
X to the 4 plus x.
Yeah. That's our derivative. Okay? Once you get the hang of the pattern that the chain rule gives you every time, we want to be able to just write down the answers. Okay? Now, you have things like E where we have a double chain. We have the 2x plus 1 inside the natural log, and that is inside the cube. Alright, so you're going to have to do chain rule twice.
What would you do first there?
Work from the outside in. The outermost function is the cube,
So what
and then when you're doing the derivative of the inside you've got to do the chain rule with.
since we're starting for E, since we're starting with the outside first, would that mean you have to find the derivative? That's what I'll need. 3 ln times 2x plus 1 to this 2x plus 1 squared or something.
3 ln of 2x plus 1, and that whole ln would be squared now. Yeah, the derivative of something cubed is 3 something squared. Okay? times the derivative of the inside. So what's the derivative of now the ln of 2x plus 1?
The derivative is, oh,
Yeah, 2 over 2x plus 1. Okay? The derivative of ln of a function is the derivative of the function 2 over the original function, 2x plus 1. So this whole thing is the derivative of e, that's our dy dx. Okay?